The job of the application layer, Layer 7, is providing services to user applications. The services consist of file sharing, message handling, and database access. Layer 7 is responsible for displaying data and images to the user in a human recognizable format. This layer also handles error recovery for applications when those errors occur. The PDU at this layer is referred to as data. The components, which consist of both client and server components, contain the protocols of HTTP, FTP, SMB, CIFS, TFTP, and SMTP. Problems within the application layer could consist of missing client or server software and incompatible or obsolete commands used to communicate between a client and server. Protocols at this layer using a connectionless transport layer protocol are more vulnerable to disruptions within the network, so they must then provide their own error recovery or rely on an error recovery from the user application. To provide a common interface for user applications, including services such as reformatting data compression and encrypting data to be sent across the network, and communicates with the session layer below. It is the lowest layer at which application programmers consider data structure and presentation, instead of simply sending data in the form of datagrams or packets between hosts. It can also be seen as a translator for the network. The session layer controls the connections between computers. The session layer establishes and maintains communication, manages communication, and terminates the connections between the local and remote application. It provides for full duplex, half duplex, or simplex operation and establishes checkpointing, adjournment, termination, and restart procedures.
The transport layer breaks down data into smaller parts known as segments, each having a port address attached to it. This step is necessary so that the data being sent can meet the file size requirements of the MPU. It's the transport layer's responsibility to resolve errors that occur resulting in lost data. It provides many services to aid in sending segments to avoid these errors. One being connection-oriented, meaning data is sent in the same order it was before it was broken down to ensure it's all delivered. Another way is flow control, where the transport layer adjusts transfer rates to match the speed of the receiver. And the last one's multiplexing, where it combines the data into one signal that can be sent over a shared medium, which conserves resources. The transport layer then sends the data between applications.
The third layer, the network layer, handles logical addressing and translates logical network addresses, or IP addresses, into physical addresses, or MAC addresses. If there are multiple ways of getting to a destination, a router attempts to find the best or fastest path to take. Access control is also handled at Layer 3 and acts like a traffic cop for network activity. The router checks a list of rules before forwarding a packet and determines whether it should be permitted to reach the intended destination. Dividing large networks into subnets can help restrict user access to resources. The PDU at Layer 3 is a packet, and software components working at this layer include IP, ARP, and ICMP. Routers, firewalls, and switches with routing capabilities, a Layer 3 switch, certain remote access devices, and essentially any device that mainly works with packets and the source and destination IP addresses in a packet work at this layer.
The data link layer is the second layer of the OSI model. It defines how computers access the network medium. MAC addresses are defined at this layer. The data link layer is actually divided into two sublayers. The MAC sublayer is used for network access, and the LLC sublayer is used for synchronization and error checking. The data link layer's protocol data unit is frame. The NIC driver is the software component that operates at this layer. Hardware components include NICs and switches. Some problems that can occur on this layer include collisions and invalid frames, which can be caused by poor network design, line noise, or problems with the NIC driver. The purpose of the physical layer is to convert bits into signals for outgoing messages and signals into bits for incoming messages. This layer also handles the encoding of bits by representing zeros and ones as some physical signal like an electrical voltage. Network components at this layer include all cables and connectors used on the medium, as well as any repeaters and hubs.